Today we got a hard problem 232 minimum score after removals on a tree. There is an undirected connected tree with n nodes labeled from 0 to n minus 1 and minus 1 edges. We are given 0 indexed integer array, whatever, we got some edges, and we remove two distinct edges, and then to get three components, we get XOR of components and the difference between largest smallest XOR is score of the pair. Right, so here first component is 134, this is 0, this is 2, right? And these are the values in there. So this is XOR 1, this 5, this is 1, and this is what? 8 to 1. So 8, 2, so 10 minus 1 is 9, right? Now constraints 1000. So we iterate over all edges, which we can do, just iterate over all nodes and pick their parents, right? And then when we choose first edge, right, the XOR of that subtree is just XOR of whole tree minus XOR of subtree of the node that we choose to cut from its parent. Now for the second node, it's less trivial, right? Because, okay, if it's in that subtree, that's easy. This one stays the same, and then if 2 would be underneath here, then from here we unXOR the subtree of that. If it's not in there, then we also have to XOR this root, XOR by this, and XOR by this, right? And then I guess that's it. So G, or we can do like H, 4AB in edges, HA append B, HB append. Okay, and then something is root, but I guess it doesn't matter. So let's do like XOR. Let's do DFS1, and then numzi, right, and then for u in hv. If u don't equal p, then dfs1 uv, right? So we go to the neighbor if it's not parent, and then XOR v, XOR with XOR u, right? And then we call it from 0. So that's the first computation, and now we have to do DFS2, right? Ans is this, here we return ans, and we start DFS2 from 0, right? And then, so if parent is not -1, then we try to do something, and then for u in hv, if u don't equal p, dfs2 uv, right? So we just all go over whatever, we just do DFS. You know how to do DFS. So here what we do, predecessors is empty set, or we could do this, predecessors pred in DFS2, right? Pred 2 add v, pred 2 erase v. That should work. right? And then we need to do another DFS. Actually, I should include, I should do this, right? Because, okay, then we do DFS3. Spread free set. I guess we don't have to reset it because it will reset itself. So def DFS free, right? And we will only do descendants because there is no point in doing, right? Let's say we are here, or yeah, we are here, and there is no point in doing this. When we are here, we will just check this, right? So we avoid double checking by that, and we don't need this. We just do if v not in prediction 2, then so if v is not in those predictions, then what do we do? What do we do? What do we do? What do we do? Good question. Yeah, sorry for the quiet part. If v is not in prediction 2, oh, we need to keep the predecessors of free, right? Because there are the two cases I explained, that we are in a subtree and we are not in a subtree, right? So pred free add v, and then I don't know, it's erased in C++, I guess. So if it's not in there, right, then we can do something. And then there are two cases, right? So sub 1 is just XOR of root, right? XOR with XOR of v, right? And then sub 2 is XOR of v. And on sub 3 is XOR of Yeah, that's not good. Root 2, right? For you in HV, if you not in, if you don't equal P DFS free, you root to V, right? Right, and then this is like that. And now we will have to modify this, right? Because we pretend we do this first, and then if let's do XOR root 3, right? And then sub2 is root 2 and this is XOR 3. And now what could happen? Well, if root 2 in predecessor 3 if root 2 in predictions, so if predecessors, so if in our current predecessors is there, then what we have to do is we do sub 1 XOR with XOR of, we don't have root 3, just this, so we unXOR that part, because that means that if 2 is here, then we unXOR this thing, and then if we would XOR this, then that doesn't work out. So then here we have to also XOR V, right? And then ans max ans, and then it's max sub 1 sub 2 sub 3 minus min sub 1 sub 2 sub 3. And I have to do non-local. Okay, somehow we got to 15, because why not? Print v root 2 pred 2 pred 3 sub 1 sub 2 sub 3. Let's check it. Okay, so in my example I have it flipped. So we cut from here and cut from here, so result should be same. So 1, 5, and then XOR of this is 10. If we cut 3 and 1, then XOR of this is 0. How come if I cut this part and then this part, then I got this, this, and this? Minimum score. Okay. Okay, well, max could be what? What are the values? 10 to 8. So it's like let's do like, I don't know. Let's do it like that, and then we do minimum here, and that's it. Okay, that should work. I hope I don't get TLE because it's not the fastest solution. Damn, I beat okay, I thought I beat everyone, but I'm at the very tail end of this thing. Oh well, I actually don't need to do this. Let's try one more time if that helps. Avoiding those non-local. Okay, doesn't. Double DFS to partition connected components, enumeration based on yeah, I mean that's faster way of checking that, I guess. Oh wow, okay, that's way simpler. Wow. Okay, I mean that's a good solution, I guess. Okay, whatever. Okay. Just try all pairs of edges. How to calculate XOR of each component. Say we picked H going to parent from B and from U, and the root is 0. If we have just two components, their XOR is and we have calculated each subtree's XOR with DFS starting from root 0. If we just from V, then the XORs are okay, so then the XORs of the components are XOR 0 and XOR V. If we also erase the second edge from there is a few cases. While assuming that U and U is not ancestor of V, then there are a few cases then there are two cases. U is descendant of V, in which case only the second XOR changes to XOR V, XOR U, and the XOR is just XOR U. U is not a descendant of V, in which case only the first XOR 0, XOR V, XOR U, since we now have to erase both three to get the ON squared, since we try ON squared edges where the number of vertices each combination we calculate the source in O1, since we can recalculate all XORs in ON with a single or sub-3 XORs with a single pass and with a single DFS, and if we use set of current vertices ancestors, we can check the ancestor condition in O1 ON. We have to store the edges in an empty list, and our ancestor lists can have up to, okay, this time it's a Google hard problem, because I already did a hard problem today and it wasn't from Google accidentally, so goodbye.